No, I guess I should record this. pH plus POH equals 14. Once again, 14 minus POH will give you the pH, and POH 14 minus the pH there. So once again, calculate the mass of sodium hydroxide to make 11.5 pH, right? Fairly strong base. So how much, basically what we're asking you here is how much of this do I have to put into 250 milliliters, or 200 milliliters, sorry, to make that pH? Well, once again, where does 200 go? Well, it goes here, okay? It could go here, and it could go here. Remember, initially, when you make this solution, you are going to be taking that mass and putting it into 200, so you will have that initially sodium hydroxide solid in water, and then it's going to break up into those two ions there, of course, in the same amount of water, same volume of water. The question becomes, where am I going to put pH here? 11.50. Where does pH go here? Left, middle, or right? Left, middle, or right? pH. Where do you think I should put it? Or one other option I'll give you. Huh? I don't know. I would say probably left, middle, or right, or another option. Let's go with another option. Maybe. You're right. I mean, what does it closely match up to? It does match up to that eventually. But for right now, what does pH measure? pH measures what? Hydronium ions, right? Do we have hydronium ions up here? No. So we probably shouldn't put pH anywhere up here, right? Maybe over to the side somewhere. The pH is 11.50. The POH would be 2.50. Okay? Once again, because those two have to add up to 14. Okay, that's the previous page here, basically. So those two have to add up to 14. Okay, so that's what I would use right off the bat. I would do that conversion, put that there. Okay, well, let's see here. I'm looking for the mass, right? So what else do I have to know about, if I'm looking for the mass here, what else do I have to know? I have to know N and big M, right? And by the way, I know big M, it's 40. I've done that one a few times, so it's 40. How am I going to find N? Yep. Yep, so we're going to find the concentration. Now, this is a good question because we've done a lot of negative log stuff, right? Which tells you the pH or the POH. But if I have the POH or the pH, how do I get back to concentration? We forget about these formulas, right? And you would say 10 to the negative 2.50 would give me the concentration. 10 to the negative pH or 10 to the negative POH gives me the concentration of those two, depending on which one we're doing, yes? Okay? These two formulas, well, actually, they're the same formulas, guys, but there's one for pH and there's one for POH. They're all the same formulas. They're on the back of your periodic table, okay? So don't forget about these, obviously. So 10 to the negative 2.50 is 0.00316 moles per liter. Tells you the concentration. I have the concentration, I have the volume. I will now find N from those two. I will simply multiply those two together, and I will get N over here, which is 6.32 times 10 to the negative 4 moles. Now that I have that, 6.32 times 10 to the negative 4, I know how many moles I have of hydroxide that's produced. Well, guess what? It's a 1-to-1 ratio, so I'm going to move that over to here. You can say times 1 or divide by 1 or whatever you want to do, but basically it's going to be the same. 6.32 times 10 to the negative 4 moles here. Still on my calculator, of course. I'm going to multiply that with the molar mass, times it by 40, and I get 0.02529 grams. Okay? And then we'll talk about significant digits. Okay? That's a good question, because that kind of goes backwards, where I gave you the pH or the POH, and we have to get the concentration with V to get you N, get you back over here on this side. Okay. Let's see. How many significant digits here? 3. How many here in this number here? 2. So only the 0.50 counts, right? The number in the front doesn't. So only the 0.50 counts. So 2, right? So 2 and 3 throughout the whole question leaves me with 2 at the end. So I need to have, remember, 0.025 grams would be my final answer. Only the 2 and 5 count there, the zeros in the front don't, right? So 0.025 grams. All right? Good questions? So that's kind of what you're going to see today as far as pH versus POH and how they're related and how we're going to get from one to the other kind of thing. Okay? Good? Yeah? Okay. We'll look at the next one. The next one is kind of similar to the ones we did last day, but there will be just one extra step. So once again, if you weren't here last day, this is basically what we did. The only difference would have been on Friday, I guess, when we kind of did these questions. I would have said, for Friday, I would have said calculate the pH of this solution, and today I'm asking for the POH. But it's going to be the exact same steps as we would have done on Friday. Okay. To calculate the POH, we'd have to find the hydroxide ion concentration, but we have an acid here, HCl. So I would take this HCl, it's a gas apparently, of course, react it with some water, modified Arrhenius definition. It is a strong acid, so it completely dissociates, which is important for us, by the way, and it would give you that there. So all that HCl would turn into H3O+, right? And if you want help with those equations, they don't get really any more tricky than that. All acids have to react with water to produce H3O+. And then whatever's left over, of course, is just what's left over. In this case, the Cl-, so Cl-. If we were doing hydrobromic, it would be Br, so Br-, of course. Okay? And so on and so on. We have, it tells us here, we took 0.450 grams of this gas, so roughly about a half a gram, 0.45 grams. We put it into 4 liters. Where can 4 liters go? Well, you could put it here, probably, you could argue with that, but definitely here. 4 liters. Most certainly here, and most certainly here. Okay. And once again, like I told you before, this is just concentration of individual ion stuff, right? Let's see. I need to find the POH. This question doesn't really, I'm going to tell you right now, is probably not very legit, because I would never say, hey, let's find the POH of an acid. I wouldn't even say, let's, would we find the pH of would we find the pH of an acid? Sure. Would we find the POH of a base? Probably not. In most cases, we'd find the pH. So everything kind of links more to pH than it does to POH. But I mean, we still ask you this question, I guess. But calculate the POH. Well, we don't have any hydroxide up here per se. Anyway, we have the hydronium ion here instead. So I guess the first thing we should maybe do is find the pH, and then we could subtract that from 14 to find the POH. So we will first find pH, which of course we want to go right here, because that's what it measures, right? In order to find the pH, we did this last day, guys, on Friday. We need to know those two things there. How am I going to find C and N? Well, I need to find N. Let's see. Molar mass, 36.46 grams per mole. And N. Okay. So let's see here. 0.450 divided by 36.46. We get 0.0123. Happens to be a 1-to-1. Okay. And the acids that we do will be monoprotic or 1-to-1, so we don't have to worry about that. So 0.0123. N divided by V, of course, divided by 4. So 0.003 moles per liter. And to find the pH, of course, we would take the negative log, and we get 2.51 0.066, etc., etc. So if we did this question on Friday, that's exactly where we would finish. We'd round it, etc., etc. Today, we want to find the pOH, so we just simply need to do that one little extra step here. We would take 14 minus 2.51066, etc., etc. And we'd get 11.489. That's actually your final answer, because look, three significant digits here, 3 here, so we need 3 after the decimal, right? So 0.489, those are the significant ones there. So that would be your pOH. Okay? If you think about this, okay, I mean, it doesn't just base on this, but if you think about the actual what you have here, and you do have to realize it's a gas, and there's lots of factors here, but 0.450 grams, that's a half of a gram. When I met, you know, if you, and it is a gas, of course, but that's not a lot, okay? You're going to take about a half a gram and put it into 4 liters of water. 4 liters of water is like a lot, right? I don't even know, I don't have anything that really represents that, but it's quite a bit, okay? 4 liters of water. It'd be like 2 big pop bottles, and it's a half a gram in 2 of those big pop bottles kind of thing. Or, you know, if a 4-liter jug of milk. If you took a half a gram and put it into like a 4-liter jug of milk kind of container of water, you get a pH of 2.5. That's pretty strong, okay? And that's only a half a gram in that much water. So, right? So anyway, that's what you're going to be doing today, okay? Before we do that, I'll just show you a couple more real quick here. Some things to note here when you're doing questions today. They're going to give you, you know, they might give you this and ask you for what's the pH, right? So you have to ask yourself, basically, with these questions and when quizzes and tests come up, does that and that go together? Do they measure the same thing? Does pH measure H3O plus? Yeah. So this is nothing more than, you know, maybe a negative log question. So maybe if I want to find the pH, I take the negative log, right, of that. Or if I wanted to do the reverse, if they told me the pH, maybe I do 10 to the negative pH here. Yeah? That's all, right? However, you have to make sure that they match up. Just like, for example, you know, I think we know this already, but these two go together, right? Those two go together. So we, you know, same thing. Just type it in your calculator, done. But when they give you this, and they ask you for the pH, those don't match up, right? So what you have to remember is at some point, depending on what they give you here, at some point you will have to use the fact that pH and pOH added together gives you 14. Okay? You might have to do it as the first step, or you might have to do it at the end, depending on which way you're going. But you have to make sure that those two match up. So right now they don't. Let's say they give you a pH of 5, let's say, well, whatever, it doesn't matter, 9. Well, the pOH, of course, would be 5 then, right? Now, these two match up, so I could do my question, right? Or vice versa. You know, if we're going the other way, you might have to do it at the end. So just kind of keep that in mind when you're doing the first set of questions. Make sure those match up, and if they don't, you just can't plug numbers in. You got to fix it, okay? Otherwise, you're going to get, and that happens quite often. So if you don't fix it right away, you'll get the complete opposite of what you're supposed to get, okay? And it turns out to be very, very, very different, obviously. So just make sure. There will be some questions today as far as practice questions like the two I went over with you today too. So there will be some that you have to write out an equation for. So make sure you do that as well. You know, if it talks about, for example, if it talks about HCl, I don't know, and let's say it asks you about pOH, well, remember, you don't measure pH of HCl, okay? You measure pH of H3O plus, right? So I'd say in this case here, probably should have an equation. If they're talking about barium hydroxide, right? And they want to know what's the pH, or the pH is this kind of thing. Well, once again, pH doesn't measure barium hydroxide. pOH measures hydroxide. Then you could get pH from that if you wanted to at the end, or whatever the case might be. There's a relationship there. But we should have an equation probably for this with hydroxide and figuring out stuff about hydroxide, right? Okay. Good. Any questions, anyone?